Alright, welcome to section 6.1, Modeling with Polynomials. We started today with a couple of sketches here. We started with an equilateral triangle that had three equal sides. And if we talked about the perimeter, you correctly showed that if we added the three sides, we would get 3s. S plus S plus S was equal to 3s. This is an example of a linear quantity, something that we can measure in a straight line if we sort of unfolded the triangle. And also something that we could talk about as having degree 1. If you look at the exponent on the s, that exponent of 1, that helps us identify this term as having 1 degree, or a degree of 1, first degree. Then we looked at a square with 4 equal sides, again side lengths of s. We could figure out that the perimeter was s plus s plus s plus s, the 4 s's, and if we added them together, then we got a perimeter of 4s. We could also look at the area easily of a shape like this. Area of a square we figure out as s times s, or s squared. You'll notice perimeter again, a linear quantity, has a degree of 1. The exponent on the 4s is a 1 there. But for the area, that's a different kind of quantity. It's an area. I guess it's an area. The exponent on the s is a 2. That means that s squared has degree of 2, whatever the exponent is equal to. We went on to a rectangle with a length of L and a width of W. When asked to find the perimeter of that, you correctly showed that you would go L plus W plus L plus W. You can add the like terms, so you can add the L's together to get 2L and the W's to get 2W. The area is going to be L times W, which doesn't really simplify to much else than LW. When we look at the degree of the perimeter, or that polynomial, the L has a 1, the W has a 1, so we say that that polynomial has degree of 1. The area, though, has L has 1, W has 1, but they're being multiplied together. So we add those exponents and we get degree of 2. That's our exponent sum. Now, 2x plus n 3x squared and 4a squared b and c are all examples of something called a monomial. A monomial just means a single term. At least one variable with natural number exponents that may also have a coefficient. The coefficients are the numbers in front, the 2, the 3, the 4, or the 1 that's in front of that c. (3x minus 1), 2a plus b, 1/2 x squared minus 2x, those are all examples of binomials. And binomials have two terms that are added or subtracted. They may also contain a constant term, like that -1. You'll notice it has no variable. And finally, ab plus 2bc minus 3ca, or x squared plus 2x plus 3, are trinomials. They have 3 terms. You can read the notes here. All of the above are examples of what we call polynomials, and we'll be working with a lot of polynomials as you go through Math 9, 10, 11, and 12. So poly just means many, so many terms in this case. All of the terms, remember, being separated by additions or subtractions. So a polynomial is an algebraic expression consisting of the sum or difference of one or more terms, or one or more numbers, like constants and terms. Terms will contain variables with natural number exponents. I guess there's whole number exponents too. You could have 1, or let's say 2c0 to the power of 0. The c to the 0 becomes 1, so you're just left with a 2. which means you end up with a constant term. I prefer to think of it as having natural numbers with constant terms. So I wrote down here, you'll notice the similarity, 3x plus y squared plus z, a trinomial, 3 terms, highest degree is 2, whereas 3x y squared z altogether with no addition subtractions is a monomial, and the exponent sum, the 1, the 2, and the 1, give this a degree of 4. In our equilateral triangle, if you'll remember, with 3 equal sides, we added the like terms. We added the s's to get 3 s's. So if terms are similar, they can be added or subtracted. So something like 3x squared plus 6x squared, you'll notice that the x squared, the variable and the exponent, are the same for both terms. So we can add the coefficients together. The 3 and the 6 add to make 9. The variable and the exponent doesn't change. It just stays there. It's like saying 3 apples plus 6 apples equals 9 apples. My apples don't mutate and change. They just stay the same. I just have more of them. In something like 3x squared minus 2x plus 4x minus 1, you'll notice the highlighted part are similar terms. So I can combine those to simplify things and get 3x squared plus 2x minus 1. Two xy plus 3yx are a little bit different, but they're also like terms. The order of the letters doesn't matter. So combine the coefficients, 2 plus 3 is 5, and then write the letters, the variables, in alphabetical order to get 5xy. Your assignment is brief, simply question 4, 5, and then 7 to 10 and 14 on page 281. Okay, have that done for Thursday.